And this, solids, liquids, and gases, each that act very differently. Solids keeping their shape, liquids filling up a shape of a container only so far, or a gas expanding everywhere, totally qualify as being different states of matter. But what happens if we keep heating the gas? Let's keep heating that water molecule, right? H2O. So we got an oxygen and we've got a couple hydrogens stuck onto it. Well, if I keep putting energy into this, one of the first things I'll do is I'll break these bonds, right? I'll actually make this so I now have hydrogen atoms and oxygen atoms running around, still as a gas. But let's look a little closer at this hydrogen atom. What is it really? It's really a proton in the middle with an electron going around it. The electron is negative, the proton is positive. It really doesn't go in a circle, it's an electron distribution cloud, but the basic idea. If I keep putting in energy, what's going to happen is that I will rip that electron off from the proton. Instead of it going around in a circle, instead of it being bound as an atom, this electron may be going this way, this proton that way. And it won't just be one electron and proton. What I will get is a plasma, a hot, ionized gas. This is really the dominant state of matter in the universe. How dominant? Well, something like 99.9% of all the mass in the universe is not a solid, a liquid, or a gas. It's a plasma. The stars are plasma. Much of the interstellar material, the gas, is actually charged. It's a plasma. And having a plasma here on Earth is not as unusual as you think either. The ancient Greeks thought of all matter made up of four things. They said, well, you know, you've got Earth, solid. You've got wind, gas. You got water, liquid, and of course, you have fire. Fire is a plasma. And if you think about it, plasmas do not take the shape of their container like a gas would. Look at this simple plasma ball experiment. It's an empty glass ball with gas in it, some cleverly positioned electrodes. When you turn it on, you get a plasma. And as you see those dancing tendrils in there, you can tell that is not a liquid, a solid, or a gas. It acts extremely differently. Charged particles interact with each other. I like to think of a plasma as gaseous jello. You have long-range forces between the electrons and ions that interact and pull together, but not too close, since the similar charged ones also repel. There are a couple direct ways to make a plasma, as I'll show in my lab.